This project is presented to you by mechatronics graduate students at Michigan Technological University. Each year it is estimated that 2.6 trillion pounds of trash is produced worldwide. This has generated an increase in demand for recycling and recycling processes. With Industry 4.0 and modern technological advancements, automation and vision systems have opened up avenues for new recycling methods. In this project, we will be demonstrating a PLC automated recyclable garbage sorter. To break down the project workflow, we have multiple components in the system. Firstly is the PLC side. For this project, we will be using Allen Bradley PLCs and a CompactLogix HMI interface. Once the HMI receives a start command from a worker, the PLC will begin the cycle. The PLC then sends a command to a conveyor belt to begin moving. Next, the recycled product will pass a camera system connected to a compute device. This compute device will read images real time. Once the images have been read, an AI neural network will interpret the image and determine what class of recyclable is present on the conveyor belt. The computer then sends a digital output back to the PLC. Once the PLC receives the bit for either paper, plastic, or aluminum, the conveyor will stop at a sort point. Here the PLC will actuate a motor if the product is plastic or aluminum, allowing paper to pass through. Next, we have a flowchart of the entire cycle. As seen here, the process is continuous once started and only will stop by the input of a user. Next, we will be discussing how the camera system interprets what type of product is on the conveyor belt. An AI neural network was selected for its adaptability of different products. An AI network can easily distinguish many different shapes, colors, and features of recycled product. For the algorithm used in this project, YOLO version 5 was selected for its ease of use and implementation. We have fed approximately 2,000 labeled images into the training network and classified recycled products into 3 classes. Here is the code written and a simple training demonstration. After about 4 hours of training, we have our results. Here we can analyze the confusion matrix to see how classes were differentiated. In the figure, one can see a contingency table of the training procedure. This matrix is a tool for statistical classification in determining the performance of the AI algorithm. Each row represents instances of an actual class, while each column represents instances of a predicted class. The scores range from 0 to 1, where 1 is a perfect representation of the expected class with the predicted class. For example, cans were correctly distinguished from the background 88% of the time, while paper was only correctly identified 75% of the time. While a score of 90% above is desirable, this is sufficient for the purpose of the project, considering that the background will be solid. The mean average precision score is the most important score when determining the quality of a model. This metric evaluates the object detection model as a whole. This is done by determining the intersection over union at 0.5 or 50% overlap. This model is able to achieve a MAP 50 score of 0.86 and is accepted. The MAP 50 to 95 is similar to that of the MAP 50 score, but it has an IOU range of 0.5 to 0.95. This is a much broader view of the model's performance in regard to intersection over union, achieving a score of approximately 0.7. For more information on this topic and explanation of the other parameters, feel free to visit ultralytics.com. Now that the training is complete, we can write our PLC routines and implement a final Python code implementation for the vision process. Proceeding, you'll see a final demonstration of the garbage sorter.